Hi everyone. So there are a few things that I wanted to show you in Excel that may be helpful as you continue to think about analyzing the falling mass rotating pulley data. Okay. So as I mentioned, right, what we need to be able to do is to measure the acceleration of our falling mass, and we can do that by measuring the angular acceleration of our pulley. So I've set up a basic spreadsheet here. I think you all have the wherewithal to figure out how to set this up, so I won't go through it in detail. So we have the raw counts from our from one of the data runs from a data run I did last week. I think this is a different one than what I sent you, but just playing around with it. So I've converted this into period is maybe not quite the right word, but it's converting the counts to a time interval by dividing by the clock frequency here, 10 kilohertz. I then calculated the angular velocity omega, right? Right, that's that comes from taking a third of a rotation, which is 2 pi over 3 radians, and dividing by this time. I also calculated theta, assuming that theta is 0 at the first point, and then I calculated omega squared. Now I've looked at the data sort of by graphing it, and I can tell that I only want to select a subset of the points, the ones that I've highlighted in green. So what I'll do is I'll show you some things about curve fitting here and about adding error bars that may be helpful. So let's start off by getting a basic plot of this data. So I'm going to insert a chart, and we're going to want a scatter plot here. And you can in fact see that for the highlighted data, right, I do indeed have something that looks linear when I plot omega squared on the vertical axis and theta in radians on the horizontal axis. So that's good. Now, we often want to we want to get the slope of this, right? Because that's going to be physically significant. You've learned one way to do that, and that is I can add a trend line, right? And that will, and if I go, and I can, if I go to the plot layout, whoops, here we go. Where is it? If I add a format axis, right, I can add, should be able to add I can add the equation of my trend line, and I can use that to get my slope. Now, often we want to be able to do a little bit better than that, and that we also want to have some sense of the uncertainty. We've talked about in the manual how one can sort of manually fiddle with the slope and the intercept to be able to estimate the uncertainty and the best fit slope and intercept. But I want to show you one other way to do it using the LINEST function in Excel. So let's do that. I'm gonna select here I'm gonna just LINEST is a function, and you can look that up. I'm going to here define this, pick a cell, and I'm going to use a formula. So I'm going to use LINEST, and then I need to give the data that I want to use. Now, if you look up the documentation for this function, you want the Y data first. So I'll select, so it's F3 to F10. I then need my X data, which is E3 to E10, E10. And then there's two other things. I don't want to force 0, 0 to be included, so I will. So there's a command. There's a keyword true for that. There's also a keyword for give me all the statistics. So I'm going to also select that, and then close that off. Now you'll notice right off that I get a number here, and that number is the slope that I got from my trend line. What's powerful about LINEST is that I can actually get a lot more information than that. So LINEST is what's called an array function in Excel, so its output actually extends over a bunch of cells. If we're doing a linear fit like this, we actually want 2 rows and 5 columns. So what I'm going to do is whoops, I did not want to do that. I'm going to highlight 2 rows and 5 columns. I'm going to click in this formula bar here, and then the tricky thing that took me a while to figure out what you need to press is Control Shift Enter. So I'll do that now. So Control Shift Enter, and now we have a whole bunch of numbers. So I'll label what's important here. So this is our slope, right, and then this, the minus 1665, is our intercept, right, and then the important things to take away are the following. So this is a value, and then here is a statistical uncertainty. Now, what I need to emphasize is that this statistical uncertainty is only calculated based on looking at the deviations between the best fit line and the data points, right? It does not account for any uncertainty in the data points. That may be pretty good when the error bars are small, and that's the case for these. I would argue for these omega squared versus theta data. So if we assume sort of a 1 count uncertainty, in here, right, we're in all cases we've got a less than 1% uncertainty in the counts, and similarly, we know the pulley is rotating, right? So by a third of a rotation. So I would argue that the uncertainty in theta is pretty small. So in cases like this, right, LINEST is really useful for getting some uncertainty on the slope and on the intercept here. Okay. So I've shown you the trend line. So I'm going to just delete that for a second, just to show you another way to get the same information, and that can be something that can be really useful. Anytime you fit a model to data computationally, it's always really helpful to plot that model against your original data points. So I'm going to do that now. So I'm going to set up a calculation. So I'm going to set up this row to calculate the best fit values based on the model that I have right here. So right, so this is a line, right? So I want so let's see, let's get my slope first. So my slope is in cell I2 times my angle, which is E2. And the reason I put the dollar signs here is to make this an absolute reference rather than a relative one, so that when I fill down below, it'll always refer to this particular cell rather than sort of going down the column here. So we've got our slope times our sort of x coordinate, which is our angle. And now I need to add my intercept. So that's also an absolute reference. So that's J2 plus J2. And now let me fill in, let me just fill in here. So I can do that by just dragging. Okay, so that looks pretty good. So now I just want to be able to plot that. So I'm gonna see. I can several ways to do this. I can go to chart. Oops. I can select data, and what I'll do is I'll add a new series here. So if I do a new series, I will now be able to select my x and y values. So let me just click in that x values box. Once again, I want my angles, and I highlight that. My y values, I want to click in there and then highlight my best fit model. And that looks good, so that, and then if I hit OK, okay, so now it's plotting the best fit model in orange, right, as dots, but that's not what I really want. I really want to see this as a line. So one way to fix that, I can zoom in, I can click on one of these points, and then if I so if I right click or whoops, or sort of control click here, I can do format data, and then data point, and then series options. I can change this to change the line and marker style, so I can turn this on to a solid line. Actually, I want all of those points. So let me just let me undo that. Whoops. So let me just select all of these. Okay, there we go. Now solid line, which that looks great, and then I'll turn the marker off. So now we have our original data points in. We'll zoom back out. We have our original data points in blue and our best fit line in orange, calculated using the values from LINEST. A couple other things. So this chart is not, this graph is not complete. You should add a title. I won't do that here, but one sort of huge pet peeve for me, you should always, always, always label your axes. So I'm gonna do that. I'm gonna add axis title here. So in chart design, add chart element. So this is theta in radians. I'll add that. And then I'll add vertical, so let's change that to omega squared and radians squared per second squared. So that's better now. And then I think you can similarly add a title if you wanted to. I also want to show you how to add error bars here. So we don't actually have error bars for these data, but let's suppose we did. Let me just insert another column here. There we go. Just to give us a little more room. If I wanted to add error bars, I could always do that by going to my graph here, and again, I can add chart element error bars. And if you go to more error bars options, you can always do error bars based on series. And so so if I want to add error bars to series 1, and then I can add, say, a fixed value. So I can do a fixed value here. So for vertical, I can get I can add a vertical error bar here if I wanted to. That seems to have added a horizontal error bar. But yeah, that gives you the ability to add error. Oh, there we go. Now I can add that. So I can like change a fixed. I can make it a fixed value. If I go to custom, I can feed it a column of my spreadsheet if I wanted to. So those are just some things that you can do as you sort of go to the second part of this, which is analyzing the acceleration for different masses. So one other point I wanted to make, sort of doing the best fit model this way is where you can like tune the slope, is a really good way to estimate the uncertainty in the slope and intercept when you do have uh, error bars in your data, and you can't just rely on the statistical results from LINEST, and you'll probably need to do that for the when we look at 1 over acceleration versus 1 over mass. Okay, so we've seen how to do a few things. We've seen here how to use LINEST in Excel. We've seen how to sort of calculate and plot a best fit model to data. And so I think you have the wherewithal now to be able to calculate the acceleration given sort of the raw counts from our setup, and then you'll also be able to extend this analysis to our model where we're going to eventually calculate and plot of 1 over the acceleration versus 1 over mass. And as I mentioned in the main video, please do all the analysis in different tabs in your spreadsheet. So I can add a new sheet here, and then you can so you can work with that. And so just to keep everything well organized. All right, so thanks very much, and I'll see you all on Thursday.